if you have a triangle and you want to learn some more information about its angles or its side lengths, but say it's not a right triangle, so we can't just use trig functions like we might normally use, you still have some tools at your disposal. And one of the tools that you have is called the law of sines. So if we take an angle, big A, and we take a side length opposite of that angle, little a, and then we can do another angle, big B, and we take the side length opposite of that angle and call it little b, well, sine of big A over little a equals sine of big B over little b. And that is also true for the last angle of your triangle. So let's call this last angle C, and this side length little c. Both my C's look kind of little, but let's assume this one at the top is a capital C. Then we have sine of big C over little c is also equal to these other ratios. So that's really all that the law of sine says, that the ratio of the sine of an angle to its opposite side is constant throughout a triangle. So now that we've learned about the law of sines, why don't we try applying it to a reasonably challenging practice problem? This problem is taken directly from the SAT Subject Test 2 for math. So this is not a problem that would even show up on the SAT itself, as they do not ask questions about the law of sines. This is a question that would be considered a challenging question to a very hard question on the ACT, but in actuality, it's really not that bad. So let's jump right into it. So first off, we're given that AB equals BC, so we know that this side also equals 10. And then we're given that angle C has a measure of 40 degrees. So this is 40. Well, we can already see that we have an angle and its opposite side. So we can utilize our law of sines. So we know that sine of 40 over 10 equals all of the other ratios of angles and their opposite sides in this triangle. So let's see what we've got. All right, so we have angle A down here. And we also have the opposite side of angle A. So we also know that sine of A, whatever that angle is, over 10 equals sine of 40 over 10. Well, we don't even have to do any real math here. We can immediately see that 40 is equal to 40, right? So sine of A has to be sine of 40. So this angle down here has to be 40. Now, 40 plus 40 is 80, and we know that we have 180 total degrees within a triangle. So this last angle up here has to be 100 degrees. And now we have all that we need to solve our problem. We know that sine of 100 over x equals sine of 40 over 10. Well, if we do a little bit of algebra, we can rearrange to get that x equals sine of 100 over sine of 40 over 10. And that just comes out, once we plug that into our calculator, to equal approximately 15.3. And that's it. We used our law of sines and applied it to a reasonably challenging problem to solve for an unknown side with very limited information about the triangle. Did this video help you out? If so, please consider leaving a like and subscribing if you'd like more standardized test or college prep help in the future. With that being said, thanks very much for watching the video and keep improving those scores. If you're interested in taking your studying to the next level, head on over to my website, cresstutoring.com, where I offer one-on-one tutoring sessions via video call. For the next 10 students who apply, I'll be offering 50% off of our first 3 lessons together.